Hello, and welcome to a tutorial on how to use SPEKTR from the command line. Let's begin by generating a spectrum using the function SPEKTR spectrum. SPEKTR spectrum's first argument defines the spectrum's 2 potential in kilovolts, and it accepts integers between 20 and 150. With the second and third arguments, users define the thickness of aluminum filtration in millimeters and the spectral model used to generate the spectrum. The last argument allows users to normalize the tube output of a TAS-mix spectrum to the tube output of a TAS-MIP spectrum. These arguments can be used to generate a variety of different spectra. We will begin by creating an unfiltered TAS-mix spectrum by setting the spectral model to TAS-mix and the normalize argument to 0. Plotting this, we can visualize our spectrum. To generate a TAS-MIP spectrum, we can set the spectral model to TAS-MIP. Plotting this, we can see that there's a difference between an unfiltered TAS-mix spectrum and a TAS-MIP spectrum. In order to make these spectra more similar, we can set the spectral model to TAS-mix and the normalize argument to 1. Plotting this, we see that the green normalized TAS-mix spectrum is indeed more similar to the TAS-MIP spectrum shown in red. SPEKTR also allows users to filter spectra using elemental filters with the function SPEKTR. This function takes in an input spectrum and an n×2 vector containing the atomic number of the filter element and its corresponding thickness. To filter a spectrum with 1 mm of aluminum and 0.05 mm of tungsten, the following function call can be used. To show the effects of the filtration upon our spectrum, let's plot this function, where the green is the unfiltered spectrum and the red is the filtered spectrum. Equivalently, SPEKTR can be called with the cell array containing the element's symbol as a string within the first column and its corresponding thickness in the second. To show that these two versions of SPEKTR are equivalent, let's plot them on the same set of axes. To filter a spectrum with a compound, SPEKTR compounds NIST is used. It accepts an input spectrum and a list of compound filters and their corresponding thicknesses. The compound filters used are denoted using either a double array containing the row number of the compound filter shown within SPEKTR compounds list.m, or a cell array containing the compound name as a string. To filter a spectrum with 0.25 mm of bone and 2 mm of fat, the following two function calls can be used. To show that these two function calls are equivalent, let's plot them on the same set of axes. To calculate the exposure, fluence per exposure, air kerma, fluence per air kerma, and mean energy of our spectrum, we can use the following function calls, where a spectrum is passed as the first argument. To calculate these values for our compound filtered spectrum, let's run this segment, and the outputted values are shown here. Thank you for watching this video, and I hope that it was helpful and informative to you.